Back to class. So the next topic is integration. Under integration, we're going to look at integration of explicit algebraic functions. We did that for differentiation. We differentiated explicit algebraic functions. We're going to also look at integration of simple trigonometric functions, and last of all, we'll talk about definite and indefinite integrals. Now, let me introduce you to integration. Integration is what I call anti-differentiation. Now, what differentiation does to a function, integration takes that result back to the function. Let me give you an example. If I have y as a function of x, let's say y is x raised to the power of 5, okay? If I differentiate this function, I'm going to have 5x raised to the power of 4. Now, integration would take this result back to the function. Now, before then, let's talk about the symbol. This symbol, like an S, is called integral. Okay, this is the integration symbol. Differentiation does not have a symbol. So this is the integration symbol, the integral. Okay, so if you see something like this, integrate a function of x with respect to x. That's what it means. Integrate this function with respect to x. So that is what integration is about. So I'll give you the formula. So for integration, if you want to integrate a function, okay, all you just need to do is, if you have x raised to the power n, if I integrate this function, okay, with respect to x, it would give me x raised to the power n plus 1 over n plus 1 plus c. Sometimes some textbooks would use k. So whether you use k or you use c, what this is called is the arbitrary constant. It's called what? The arbitrary constant. Okay, so we'll talk about that as we make progress. So when you integrate a function and you have a constant, we'll call that indefinite integral. Indefinite. It means, it can be any answer. That constant can be anything. So we call that indefinite integral. But when you integrate without a constant, when you have a final value that is a number, then that integration is a definite integral. We're going to do that in the course of our teaching today. So you see this. So let me give you an example. Look at this now. I said integration is anti-differentiation. It reverses the result of differentiation. So this is the result of differentiating this function. So if I take this down here, if I integrate this result, I am going to get the function using the rule. So if I integrate 5x raised to the power of 4 with respect to x from this rule I gave you now, this would give me 5x raised to the power 4 plus 1 over 4 plus 1 plus c. So what is 4 plus 1? 5. So this is 5x raised to the power 5 over 5 plus c. What do you see? 5 would cancel this 5. We're left with what? X raised to the power 5 plus c. Can you see? That's what we had initially. So I said integration is anti-differentiation. So it reverses the result of differentiation. So now we can also have what we call definite integrals. Now for definite integrals, as I spoke about that earlier, we're going to have values, limits, just like you have something similar to your statistics, upper bound and lower bound. So we have limits. They are called limits. So if you have a and b, they are called the limits of this integral. So we'll solve a question or solve questions so that you have an understanding of what we're talking about. So let's quickly go to a question to solve. Now, just like you have or you did for differentiation, if you have a polynomial function, like this first question taken from 2017, number 1, there's a polynomial function we're told to integrate. Now, you are going to integrate each part or each component of the polynomial function, the same way you differentiated that. If this was differentiation, we're going to differentiate each part. That is, we'll differentiate x squared, differentiate 3x, differentiate 5 or minus 5. In this case, we are also going to integrate each one of those components that make up the polynomial function. So we have the polynomial function up here. Pay rapt attention, you'll understand. Okay, so we have this, the integral of x squared plus 3x minus 5 dx. Now this is more like saying integrate x squared plus integrate 3x minus integrate 5, and everything should be dx. Or if you like to say, integrate this with respect to x, you see this, plus integrate this with respect to x, plus, minus integrate this with respect to x. So if we did what I showed you, if you followed the rule, this would give you x raised to power 2 plus 1 over 2 plus 1 plus 3x raised to power 1 plus 1. Hey, Mr. McCollins, where did you get the 1? Of course, this is 3x. 3x is the same as 3x raised to power 1. But since the power is just 1, we don't have to write that. Now, what do we do to this? Please pay attention. Now, 5 is the same thing as 5x raised to power 0. Because x raised to power 0 is 1, so 5 times 1 is 5. So we can write 5 as 5x raised to power 0. So if we did that, we're going to have 5x raised to power 0 plus 1 over 0 plus 1. And then we have our arbitrary constant added to it. So in this case, they have used the k. Let's use the k. So this is x raised to power 3 over 3 plus 3x raised to power 2 over 2 minus 5x. Can you see this? 0 plus 1 is 1. So there's no point writing over 1. And then plus k. So let's look for the correct option. The correct option is option B. X raised to power 3 over 3 plus 3x raised to power 2 over 2 minus 5x plus k. So the correct answer is option B. Now that is how it is solved. Now the next question is definite integral. So it's very important. I have so arranged the question so you have an understanding. So let's go. You can press pause, go over this again. Remember how we did it. We integrated each component of this polynomial function to get our answer. So we have the next question. It's similar to the one we just did. The only difference is we have the limits. So we have x squared minus 4x dx. So how do we solve this question? It's simple. So we do what we did earlier. So we integrate this. So if you integrate this, you have x raised to power 2 plus 1, right? Over 2 plus 1 minus 4x raised to power 1 plus 1 over 1 plus 1. Now take note. Now can you see what I have? I have written this. Now these are the limits. So let's finish with what we have inside here. What do we have now? This is x cubed over 3 minus 4x squared over 2 to 1. Now what do we mean by this? Now this is quite easy. We are going to substitute x for 2. We'll put 2 into x and we'll put 1 into x. We'll subtract. So let's have this. The first one we have is 2 raised to power 3 over 3 minus 4 into 2 raised to power 2 over 2. Can you see this? Then we subtract. You substitute 1 raised to power 3 over 3 minus 4 into 1 raised to power 2 over 2. So this would give me 2 raised to power 3 is 8 over 3 minus 2 times 2 is 4. 4 times 4 is 16 over 2 minus 1 raised to power 3 is 1 over 3 minus 4 times 1 raised to power 2 is 1. So 4 over 2. You see this? So the LCM here is 6. And so if the LCM is 6, we have 16 minus, what does it give you? 48. You see this? Because 2 in 6 is 3. 3 times 16 is 48. Minus LCM is 6. We have 2 minus 12. So this would give me 48 minus 16 is 32. So this is minus 32 over 6 minus 10 over 6. So if you work that out, you have minus 32 minus times minus is plus. This is over 6 plus 10 over 6. So LCM is 6. They have the same denominator. That would give me minus 32 plus 10 over 6. And minus 32 plus 10 is minus 22 over 6. 2 can go into both. 2 is a factor, a common factor. This is minus 11 and this is 3. So the answer to the question is minus 11 over 3. Let's see if we have that in the option. Yes, we do. That is option D. Option D. So we have one more question on integration, then we go to permutation and combination. Okay, thank you very much. So please, you can press pause, look at it again, try to understand what I've done. I took pains to integrate each term of this polynomial. This is actually quadratic. So I integrated each term. These are the limits. I applied the limits. How did I apply the limits? When you get to this point, just substitute the values, okay, of the limit, and then you subtract. So you subtract the lower. This is the lower limit. This is the upper limit. You arrive at the answer. That is that. Now let me give you very quickly, just like I did when I taught you differentiation, let me give you the integration of standard integrals for trig functions. Standard integrals for trig functions. Now remember I said that integration is anti-differentiation. So what differentiation gives you, integration reverses it. Okay? So remember I said if y is sine x, okay, the y dx is going to be what? Cos x. What this means is that if I integrate cos x, I should get sine x, since integration is the reverse of differentiation. So that is that. So take note of that. So if I integrate cos x with respect to x, it should give me sine x plus c. If I integrate sine x with respect to x, now this would not give me cos x. Rather, it will give me minus cos x plus c. Why, Mr. McCollings? Now, quite simply, remember that if you differentiate cos x, you get minus sine x. So that's why if I integrate sine x, I'll get minus cos x plus c. Are we okay with that? I believe that is fine. So with this, we can solve that question. Now look at this. This is very simple. We're told to evaluate the integral of sine 3x dx. Now look at this. This is not sine x. It is sine 3x. Can you remember function of a function I taught you in differentiation? Yes. There is a function sine something. There is still a function. So this function is a function of another function. So how do we solve this question? Very simple. Now let u be 3x. If u is 3x, we'll differentiate this. So du dx would be 3. Can you see this? 3. Now, we have dx here. Can you see this? dx. How do we make dx the subject here? What do you think? If du dx is 3, what do you think dx du would be? 1 over 3. Why? Because it is just the reciprocal. We have ended up doing the reciprocal. So let's have this. So go back to this integral. Integrate, or the integral of sine. We have said that 3x is u, so sine u. If we have sine u, we have to integrate this function with respect to u. So let's attempt to solve this question. Evaluate, that's 2019, number 48, sine 3x dx. Now this is a function of another function. If it was just sine x dx, it's simple. The answer would be minus cos x plus c. But it is sine 3x. So there is another function. Take note of that. There is another function here which is 3x. So let u be 3x. If we differentiate u with respect to x, we're going to get 3. The u dx is equal to 3. If the u dx is 3, now we have the x here. What this means is that this integral becomes sine u dot dx. Now, but look at this. There is no x here, so we cannot integrate u with respect to x. So we must integrate sine u with respect to u. So how do we come about that? Now come back here. It means we have to integrate this. If we attempt to integrate sine u with respect to u, what happens to this dx? Very easy. Go back here. The u dx is 3. So what do you think about dx? The x from here is simply du over 3. You can do it like that. Or alternatively, we can write this equation like this. Integral of sine u dot dx du dot du. The x du dot du. Now, mathematically, these two can cancel out. We can cancel out both of them. But the x du here would simply be the reciprocal of du dx. Du dx is the reciprocal of dx du. So what this means is that dx du would be 1 over 3, since the u dx is 3. So we can apply that here. If we try, we're going to have integral of sine u dot du 1 over 3. So we bring this 1 over 3 out of the integral sign. We have 1 over 3 integrate, or the integral of sine u dot du. So how do we integrate sine u du? It's easy. Go back to this. So this would give me minus cos u plus c. But we have a 1 over 3 here. So minus 1 over 3 cos u plus c. Remember that u was not given in the question. We assumed u to be 3x, so we can replace it. So that would give us, I'm taking it up here so that you can see clearly, minus 1 over 3 rather, cos 3x plus c. This is the answer to the question. And do we have the answer there? Yes, we do. Option B is the correct answer. So that is how to solve a question like this with trig, integration of trig function. So we have been able to do indefinite integral. We've done definite integral. Now this is integration of trig function. Okay, so the last but not the least topic we're going to consider this right now is permutation and combination. Permutation and combination. Permutation and combination. Now here we're going to talk about cyclic permutation and also permutation involving indistinguishable objects. I want you to pay attention because permutation and combination is not in your mathematics syllabus. So I want you to pay a rapt attention to this. Permutation and combination. Now when we talk about permutation, we're talking about arrangement. While combination just talks about selection. So let me give you an example. If I have 3 letters, A, B, and C. Now let's just have 2 letters, A and B. There's a question, how do I arrange A and B? Look at this. There are only 2 ways, or there are just 2 ways that I can arrange A and B. I can have B on the right side of A or on the left side of A. So I can have AB or BA. So how many ways? That's just 2. Now what if I have A, B, and C? I can have A, B, and C. This is one way. I can have A, C, B. This is another way. I can have C, A, B. This is another way. I can have C, B, A. This is another way. I can have B, C, A. This is another way. I can also have B, A, C. Can you see? 1, 2, 3, 4, 5, 6. So if I'm arranging 3 different things, I can arrange them in 6 ways. If I'm arranging 2, I can arrange them in 2 ways. So this has to do with arrangement. So this is permutation. So there is something we call factorial. If I am arranging 2 things, I can arrange them in 2 factorial ways. If I'm arranging 3 things, I arrange them in 3 factorial ways. So if I'm arranging n things, n can stand for any number of things. It's simply n factorial ways. Now what does n factorial stand for? N factorial is simply n minus 1, n minus 2, 2 you get to 4, 3, 2, 1. Now how did we arrive at this? Now this is simply repeated subtraction until you get to the last. When you subtract by 1, you keep subtracting by 1. Now how did we arrive at that? n minus 1, we subtracted 1 from n. N minus 1 is n minus 2. We just keep subtracting until we arrive at 1. So when you see factorial, that's what it means. So you keep subtracting 1 until you cannot subtract anymore. So this is what we have. Now, so permutation has to do with arrangement, while combination has to do with selection. So when you see a question like this, how do you select, a committee of 5 men from 6 men? Or maybe a committee of 5 men and 2 women from 10 men and 7 women. Now that has to do with combination. So we'll solve questions so you have an understanding of what we're talking about. Now we also have what we call cyclic permutation. Remember I said permutation has to do with what? Arrangement. Now the question is, if I have a circular table, how can I arrange people around the circular table? Let's say we have 5 people. We want to arrange 5 people around the circular table. There is no easy way to do that except the fact that we can put 1 person and arrange the other 4 people around the 1 person. We can just put 1 person and arrange the other 4. So if we have a circular table, okay, to arrange a number of people around a circular table is simply, take note, this is a constant, n minus 1 factorial ways. N minus 1 factorial ways. What did I say? N minus 1 factorial ways. Now, but if it is something that can be turned the other way, let's say those of you who make beads, if you make beads, if you have a bead, okay, now you can put those things that make up the bead. I think the whole thing is the bead. So those little things you add, you can turn it the other way. So if it is something you can turn the other way, then the formula is n minus 1 factorial over 2. We'll solve questions like that, you understand. So let's go quickly to the questions as we look at that. Now we also have another one, permutation involving indistinguishable objects. Let me explain. Now if you have the word pool. The question is, how do you arrange the letters of this word pool? Look very closely. You find that there are two letters that are the same. O. So these two are indistinguishable. Now, what do I mean by that? I mean, you don't know which one is the O. So how do you arrange something like this? So when you have indistinguishable objects like this, the easy way to solve this is simply n factorial over the number of the indistinguishable objects. Let's say you have a word like excellence. Can you see this word? Excellence. Now, excellence, in excellence, you have E, about 4 E's. You have 2 C's. You have 2 L's. Now, how do you solve this? How do you arrange these words? There's a formula. That's what we intend to get here. Now, the formula is simple. Just count the number of letters that make up the word excellence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 factorial. Then you count the letters that are indistinguishable. You can see E. We have 4 E's. So if you try to arrange, you don't know which one of these E's you put here or put there. So there are 4 E's. You have 4 factorial. There are 2 L's, 2 factorial. And then there are 2 C's, 2 factorial. This is how to arrange something like this. So very simple. So let's quickly solve questions for better understanding. There are only 3 questions here, but I have a 4th question for you which is not captured here. Now, the first question is from 2019, question 48. It says, in how many ways can 9 people be seated if 3 chairs are available? In how many ways can 9 people be seated if 3 chairs are available? Obviously, this is a permutation question. We're talking about arrangement. How do we do that? Now, it's simply 9 permutation 3. Okay, but how do we solve this? Let me quickly give you the formula for permutation. Now, if you have n PR, n, what this means is n permutation 3. Now, how do you arrange this number this way? N stands for the number, and R stands for the weight. How do you arrange n in 3 ways? In R ways, rather. Now, this is the formula. It is simply n factorial over n minus R factorial. N factorial over n minus R factorial. N factorial over n minus R factorial. I've taught you what n factorial means. N factorial is simply n minus 1, n minus 2, and so on till you get to 4 times 3 times 2 times 1. Of course, you know this tells you that there are many terms here. Okay? So this is the formula for permutation. N factorial over n minus R factorial. So let's solve this question. 9 people seated if 3 chairs are available. So that's simply 9 permutation 3. Now this is simply 9 factorial over 9 minus 3 factorial. Okay? 9 factorial over 9 minus 3 factorial. So let's solve that. This is 9 times 8 times 7. We're just doing successive multiplication down the line. Okay? Times 6 factorial. Now, why did I stop here? Look at this. Go down. What do you have? 9 minus 3 is 6. So 6 factorial. Because I want this to cancel this. So I'm left with 9 times 8 times 7. So 9 times 8 times 7. That's what we have. 9 times 8 is 72. So 72 times 7. This is 49 and 14. So 504 is the answer to this question. It's there. Option B is correct. Option B, 504. Okay, so the next question is for football fans. 2020, question number 29. 8 football clubs are to play in a league on home and away basis. Of course, you need to understand this question if you watch football a lot. Okay, probably you want to know how many matches you're going to watch in the season in Premiership or Serie A, where you have 20 clubs playing home and away. But here, this team, or the league rather, comprises of just 8 clubs. 8 clubs are to play in a league on home and away basis. The question is, how many matches are possible? How many matches are possible? Now, this is a permutation question. How many matches are possible? So that is 8 permutation 2. That's what you have. 8 permutation 2. So 8 permutation 2 is 8 factorial over 8 minus 2 factorial. You see that? Now, 8 factorial is 8 times 7 times 6 factorial. Why did I stop here? Because 8 minus 2 is 6. So we're going to have 6 factorial. So we don't just waste time. You know, it is JAMB. You need all the time in the world. So this will cancel this. We have 8 times 7. So that is what? 56. So there are 56 matches that are possible if 8 clubs are going to play home and away. So 56. Now the last question there, before I give you my own question, 2018 number 19. It says, find the number of committees that can be formed consisting of 2 men and 1 woman from 4 men and 3 women. Now listen, this is selection question, and I told you permutation has to do with arrangement. Combination has to do with selection. Now it's simple. Very, very simple. Now how do we solve the question? Now before we do that, let me give you the formula for combination. If permutation, n permutation r is simply n factorial over n minus r factorial. N combination r would be, now what does this mean? This is how do you select r from n? Remember I said combination is selection. So this is n factorial over n minus r factorial, r factorial. Mathematically, if you look very closely, you see that there is a relationship between permutation and combination. Now, what is the relationship? Very, very simple. Simply, n permutation r is simply r factorial times n combination r. You know what it means? If I multiply combination by r factorial will cancel r factorial. You see, we are back to permutation. You can see that. So there's a relationship between permutation and combination. So let's solve the question. So we want to pick 2 men from how many men? 4 men. That is 4 combination 2. This is for the men. It says and, please, when you see and, just like probability, it is multiplication. We want to pick 1 woman from 3 women. That is 3 combination 1. So we can solve that. So this is 4 factorial over, over 4 minus 2 factorial, 2 factorial from the law here, or the rule, times 3 factorial over 3 minus 1 factorial, 1 factorial. Please note that 1 factorial is 1. So let's play. We have 4 factorial over 2 factorial, 2 factorial. Now listen, do not make the mistake of saying 4 factorial over 2 factorial, 2 factorial is equal to 1, because 2 times 2, 2 times 2 is 4. No, it is wrong. It doesn't work that way. I said it does not work that way. So we're going to do something. I'll show you how this is solved. Very, very easy. You get this very easily. Now let's go. So this is 4 factorial. 4 factorial over 2 factorial, 2 factorial, times 3 factorial over 2 factorial, because 3 minus 1 is 2, right? 1 factorial. So this is 4 times 3 times, I'll decide to leave it at 2 factorial because there is a 2 factorial down there. Over 2 factorial is 2 times 1, right? Times 2 factorial times 3 times 2 factorial. Why? Because there's a 2 factorial there. 2 factorial times 1 factorial is what? 1. I said that earlier. If you look up, 1 factorial is equal to 1. Now, this will cancel this. This will cancel this. 2 times 1 is 2, so 2 will cancel this. 2. So let's go. We have 2 times 3 is what? 6 times, what do we have here? 3. This is of 3. So 6 times 3 is 18. There are 18 ways, or rather 18 committees that can be formed. Mostly you see ways for permutation. Why? Because permutation has to do with what? Arrangement. So there are 18 committees that can be formed, okay, consisting of 2 men and 1 woman, from 4 men and 3 women. I have one last question. I put it up on the board. It's from your past question. Try to solve the question if you can. If you can't, I'll solve it. And then we call it a day from there. Now, this is the question. It's a question that requires you to solve. Now, remember all this. Try to look at this. NPR, look at the formula. So, I'll erase the formula, put up the question, and then I'll solve the question. You can press pause because of my time. Solve the question when you're done. Press play and see what we have. Now, the question is, if n permutation R minus 6 open bracket n combination 4 equals to 0, find the value of n. Now, this question is from 2018, question number 17. Press pause, have a go at it. When you're done, press play and see if you're correct. Now, let's solve. Now, remember what this is. N permutation R is simply n factorial over n minus 3 factorial. Minus 6. Remember what n combination 4 is. It is n factorial over n minus 4 factorial, 4 factorial. So I'm going to take them one after the other. I'll take this one. So let's solve this one. N factorial over n minus 4 factorial, 4 factorial. Now look at this. Now this would give me n minus 1. Remember this? I taught you that. N minus 2. And then we have n minus 3. And then n minus 4 factorial. All over n minus 4 factorial, 4 factorial. Can you see? This can cancel this. We are left with n minus 1, n minus 2 over 4 factorial. Now let's quickly go. We can do 4 factorial. 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12 times 2 is 24 times 1 is 24. So this is n minus 1, n minus 2 over 24. When you see a question like this in JAMB, let it be your last question. I beg you. All right, so that's what we have. We're done with this, okay? But if we bring this 6 in there, we have 6 into n minus 1, n minus 4, all over 24. So 6 here 1, 6 here 4. That leaves us with n minus 1, n minus 4 over 4. Now, Mr. McCollins, why would JAMB set a question like this? Well, JAMB understands that many of you would like to solve a question like this. So you want to waste your time. But like you heard me, leave a question like this for You save the best for last if you think this is best. So we're done with this part. Let's deal with this part. So n factorial over n minus 3 factorial is simply n minus 1, n minus 2, n minus 3 factorial over n minus 3 factorial. So we can do this. We're left with n minus 1, n minus 2. Now we can bring them back to this, to the way it is. So, can you see this? We're done with this part. So when we bring them together, it will give us what I have on the board. So, it will give us, divide both sides. Can you see? We have this here and we have this here. If I divide both sides by all of this, I'm going to have this times 1 over, that's what it means to divide. We have this, we're almost done, n minus 1, n minus 2. So this will cancel this, leaving 1 here, equals to, there is something because of the space, I have omitted that, which I will put now, over 4 times 1 over n minus 1, n minus 2. What I did here is what I'm doing here. So this will cancel this, leaving us with 1 equals to n minus 3 over 4. So if we cross multiply, we have 4 equals to n minus 3. So n will be what? 4 plus 3, n is 7. I bet you don't want to touch this question until you have time and you're done with everything. So, take note of everything I have taught you today, everything you have written. If this is not your first time of writing JAMB, hopefully this will be the last time you write JAMB. And if this is your first, I trust that it will be the last, the only time you write JAMB. So, with that, we come to the end of today's class. Here's wishing you good luck in your exams. Have a wonderful time. Goodbye.